You see it everywhere, right? From ChatGPT writing your emails to AI generating these incredible images, there's a single technology powering this whole revolution. But how does it actually work? Well, in this explainer, we're going to lift the hood on the secret engine of modern AI, the transformer. This quote from just last year really says it all. This one single architecture, which first popped up from a team at Google back in 2017, has pretty much taken over the entire field. It's the foundation for almost every major AI breakthrough you hear about. So what is it that makes this one idea so unbelievably powerful? The entire revolution really boils down to a deceptively simple idea, one that's borrowed directly from our own brains, the ability to pay attention. We do it all the time, right? We filter out the noise and focus on what's important. Teaching a machine to do that, well, that was the absolute game changer.
Okay, so take a look at this sentence. For us, it's totally straightforward. But for a machine, that tiny little word, it, is a massive puzzle.
We know instantly that it refers to the ball. Our brains just naturally connect it with ball and heavy to get the meaning. But how can an AI, which just sees a string of ones and zeros, make that same logical leap? Before Transformers, this was a huge challenge. The solution is something called an attention mechanism, and it's a brilliant idea. Instead of treating every single word with equal importance, the model learns to give out attention scores. So, in our sentence, it figures out that to understand it needs to pay way more attention to the words ball and heavy than to the word robot. It's learning context by weighing the relationships between words. So how does this attention thing build into a whole system? Well, it's the absolute heart of the Transformers architecture, which basically has two main parts, something called an encoder and something called a decoder. And here's the basic flow. The encoder's job is to read the entire input sentence all at once. Using that cool attention mechanism, it creates this rich, detailed map of how every word relates to every other word. Then, the decoder takes that map and uses all that context to intelligently generate the output, whether that's translating a sentence, writing a summary, or answering your question. And you have to understand, this ability to process everything at once, it was a complete game changer. Older models, like RNNs, had to read a sentence one word at a time. Kind of like how we read a book. It was slow, and honestly, they'd often forget what was said at the beginning of a long paragraph. Transformers see the whole picture, all at the same time, which makes them incredibly fast and way better at understanding the overall context. This huge breakthrough in speed and context didn't just improve the stuff AI was already doing, it unlocked a whole new universe of capabilities. And suddenly, this attention mechanism is just everywhere. It's how your streaming service pays attention to the shows you like to recommend the next one. It's used in computer vision to find specific objects in a busy photo. And of course, it's the T in GPT, the very core of the large language models like ChatGPT that have completely captured everyone's imagination. With this incredible range of uses, you might be thinking the Transformer is the final answer for AI, the end of the story. But, and this is where things get really fascinating, recent research has started to find its limits, revealing some pretty fundamental and, frankly, surprising weaknesses. Yeah, it turns out that not all problems are created equal in the eyes of a transformer. Researchers have actually figured out that you can sort computational tasks into a very clear hierarchy based on how well this architecture can even handle them. This chart breaks it down perfectly. You have simple retrieval tasks, like just counting things. For a transformer, that's a piece of cake. Then you have parallelizable tasks, like figuring out if all the points in a network are connected to each other. That's tougher, but still doable if the model's big enough. But then there's this third class of problems. They're called search tasks. And this is where the transformer architecture really starts to struggle. And here's the crazy irony. The transformer's greatest strength, its superpower of seeing everything at once, is also its greatest weakness. Think about a task like finding the shortest route on a map. You have to explore different paths one step at a time. This step-by-step sequential process is the literal opposite of how a transformer is designed to think. It's a classic case of having the wrong tool for the job. Okay, so why do we care about these blind spots? Well, understanding them is absolutely critical because it basically gives us a roadmap to the next frontier of AI research. And this isn't a problem we can just solve by throwing more data or more computers at it. The research shows these are theoretical limits baked right into the design. The architecture itself is described as a bounded capacity communication protocol. A simpler way to think about it is like a pipe that has a fixed width. No matter how hard you push water through it, you can only get so much out the other end. There's a hard ceiling on what it can do. So this brings us to the big picture. The key takeaway is this beautiful duality. On one hand, transformers gave AI the power of focus, the ability to see the whole board at once, and that changed everything. But on the other hand, their inability to do that step-by-step reasoning defines the next great challenge for AI. Solving that is going to be key for things like drug discovery or complex logistics, and it'll probably mean we need brand new architectures that can do both. So, we did it. We taught machines to pay attention. The massive question for the next decade is, what do we teach them to see next? The answer to that is going to shape the future of artificial intelligence, and one thing's for sure, this revolution is far from over.